Okay, so let's refresh where we were, and let's do that because I have no idea, and y'all aren't going to tell me because y'all don't want to go over stuff. So we're just going to have to do the best we can. Let me get rid of all these pictures that I can't figure out where they keep coming from. Let's see, academics 110. I think we were still doing equations before the break. Am I correct? I don't think I got y'all ready for a test yet.
No. I'm ready for the test.
You're not going to tell me anyway, right?
I think we're still in the middle of it. We had to bounce, but we were still.
We're still working on problems, right?
I
I think so too. So we'll just do that. Because the only thing we've got left pretty much is the change-based formula.
Alright, here's the pizza stain on my thing. Now I remember. Okay, so
We got a pizza stain, so we're progressing with the memory. All right, 110.
we learned about natural log.
Yeah, we did natural log, which is the same property, so I'm not worried about that. Let me just pull up.
And we learned anytime you see an exponent with x, you're going to either have to take the exponent or the natural log.
And this is chapter 4, right? Y'all got to tell me what chapter it is. I forget.
4.1,
I think it's
Yeah, it was
5.4.
4.1. That's the last thing I wrote down.
I was thinking we were in section 4, whether chapter 5 or chapter 4. I don't know which chapter it was, but I remember section 4. We'll find out here in just a second. But I think we're finishing up the chapter. It's chapter 5. I thought it was. And 5.4 should be logarithmic functions, logarithmic equations. There we go. Yeah, we did all those type questions. Yep. We did those. That's definition of logarithm. We did those. Exponential equations. That's what we were doing. We were doing exponential equations. Which we did all of those type equations. Yeah. All right, just for memory purposes, let's do number. Which ones do y'all have the answers for? The even ones or the odd ones? Huh? Odds. Let's try 58 or 55 and 57. Let's try those two. 55 and 57. I'll blow it up for you. And just for memory purposes, let's just do two of them, and then we'll move forward. 55 and 57.
What's it equal to?
What?
Equal 1? 55?
I'm sorry, hold on. 55 says log base 5 of x equal 1, yeah. log base 5 of x plus 2 plus log base 5 of x minus 2 is equal to 1.
Priority 1 message coming in on secured channel.
Come on in.
Priority 1 message coming in on secured channel.
All right, the first one, I don't forgot which one I said, I guess 55. First thing you notice is that these two are to the same one, same base. So that means that we can rewrite that as log base 5 of x plus 2 times what? X minus 2 is equal to 1. And that looks like to me, you can rewrite it as 1 is equal to log base 5 of x minus x plus 2 times x plus 2 vice versa, then that's y is equal to log base A of what? X. And this yields this equals or yields A to the y is equal to what? X. So, if that does that, sorry, that's my son. Oh Lord. I hope my mother hadn't forgot to pick him up. Go ahead and finish that now. Sorry about this. This is one of those calls that would constitute an emergency.
Is it a V or a Y?
That was, he can't find his telephone. Sorry, I thought he was standing at the front door of the elementary school with DSS coming down. I didn't know. All right, so y is equal to 1, a is equal to 5, and x is equal to all that. So a to the y is going to be 5 to the what? 5 to the 1 is equal to x plus 2 times x minus 2. The reason I'm using a little bit darker, a little bit older, is because some students say that on here that one or two students that actually watch the video that it shows up there. So that's why I'm doing it. So 5 to the first power is 5. Is equal to x squared minus what? 4, shortcut number 3. And you can solve this two different ways. You could set equal to 0 and solve, which is the same answer as if you brought the 4 over. So 5 plus 4 is equal to x squared. 9 is equal to x squared. So what is the final answer? X is equal to positive or negative 3. And in this case, 3 is our answer because you can't take the log of what? Of a negative number. So if you go back to the original, let's go back to the original. Let's see. Negative 3 plus 2 is what? And negative 3 minus 2 is, so that would cause a problem. So your answer would be 3. Positive 3 is your answer. So as I told you before, you've got to know your properties, you got to know how to use the properties, and you got to know knowledge. Now our other problem is 57? Now, the only difference in 55 and 57 is that the right-hand side is also log base 7. And on that one, it wasn't. So log base 7 of these two guys, I'm just going to write everything out right now. 4x minus log base 7 of x plus 3 is equal to log base 7 of x. Now, if these two are written as a negative, how else can we rewrite this? As what? As division using what law? Starts with a Q. Quotient law, quotient rule of 4x over x plus 3 equals log base 7 of x. Now what's the rule here? It looks complicated, so let's clear. Is that the rule? What's the rule? Why? Because they have the same base and you have you have variables here. So that means, and there was a number here, then you can set that equal to the number or whatever. If you have the same base on both sides of the equal sign, then this guy is equal to, so that's going to be 4x over x plus 3 is equal to x. My stylus has not been working too good today. Somebody stole the styluses out of 236 today. They were trying to be funny. No, there was 3 of them. Because somebody stole them on the course. Somebody's trying to be funny. Well, the security is going to be doing something. Oh, what are you in for? Oh, I was stealing styluses.
Now you're gonna get rate for it.
X plus 3 cancels, you get 4x is equal to x times x plus 3. 4x is equal to x squared plus 3x. And bring the 4x over, minus 4x. We get 0 is equal to x squared minus x. 0 is equal to x times x minus 1. X is equal to 0, or x is equal to what? 1? Now go back to the original and make sure that you don't get a negative. And 0 plus 3, that's okay, that's okay. Looks like to me that's the answer, 0 and 1. Now, make sure you can go both ways. Make sure that you can change a logarithm into a exponent, and make sure you can change an equation into a property, or a property into an equation. And you should be able to do that with the homework in 5.4. Excuse me. Oh. There we go. Well, thought I had, there we go. Those are the questions that I would probably focus on right here in the book if you're working in the book. What would you do with this one right here before you even started? No.
Where
You could rewrite the log of x to the what power? 1/2 power. You could do that. You could square both sides, but that's not going to help you. We'll give you a 2 over here that you could move out front. You could do that. I'd either square both sides or rewrite the log base x or log of x to the 1/2 power. I would do one of those two things. And the only reason I bring that one up is I would give you that test question, not just so you could pass Math 110, but I'd give you a bunch of these on the test and homework, because whenever you see a radical, you need to learn to what? Rewrite it as a rational exponent, because that's what you're going to have to do in calculus. Okay. Let's solve a couple of these formulas right quick. These are just solving formulas. So let's do 71 and 75. Now this is just algebra and logarithms. So hold on a second. 71 and 75. And that's negative KT right there. And this is negative CX right there. Now on these type problems, you have to know your logarithmic rules, but before you even start the problem, you got to know how to do what? Algebra. Alright, T is equal to T sub O plus parentheses T sub 1 minus T sub O times 10 to the negative K T power. Now the first thing I'm going to do is get this T sub O over here, get it out of the way. So that's T minus T sub O is equal to 10 to the negative KT times T sub 1 minus T sub O. Now what else can we do to get the, all we care about is that little t, that lowercase t. We care less about the uppercase or the capital T's. So what could we do to get rid of a bunch of junk? What could we do? Say again? Divide by what? Divide by Tito over here. Ti minus T sub O. divided by t sub I minus t sub O. So now we've got t minus t sub O over t sub 1 minus t sub O, and that's equal to 10 to the negative kt power. Now what? What is the log that you would use here? Because you know you're going to take the log of both sides. Because you got to get, remember when I told you that your exponent, where is my exponent that we're solving for? I'm sorry. Where is my variable that we're solving for? Where is it? It's an exponent. And what did I tell you when you have an exponent? When you have a variable that you're solving for, and it's in the exponent, what I tell you, you're going to have to end up doing. You got to bring that. You got to bring this exponent where? Back down here. Why? Because you can't solve an exponent when it's up here. A variable when it's up here. You have to bring it down to the first floor. And the only way to do that is by doing what? Taking the natural log or log. Which one am I going to do? Why? It's log base what? And that would be log base 10 of what? Which is identical. So, let's take that across. Be nice if this thing were- I couldn't do that in a million years if I tried. Okay. So I'm going to take log base 10, which is, I'm going to write it out. Log base 10 of t minus t sub O over Tito is equal to log base 10 of 10 to the negative kt power. Now what's the rule when the base is equal to this guy? Huh? It should be. Just to make sure, we'll go back and pull up our handy dandy sheets. Real easy to pull up. You just go to Google and pull up dang old identity. Let's go to, hello, let's go to log rules. Basic log rules. There we go. There we go. There we go. That's the one I'm looking for. Look what happens when you do log base A of A. What do you get? Well, you get 1. But if you have log base A of A to the X, what do you get? So what does that exponent do? It comes down to the first floor. It comes down to here. So not ours is not X, it's what? Dang old KX, isn't it? KT or whatever. So using this rule right here, whatever's in this exponent will come what? Down. And that's what you want. So since I took the log of this guy basically turns, this right here turns to negative K times T, and this turns to all this. Log base 10 or log of T minus T sub O over T sub 1 minus T sub O is equal to negative KT. And now how do you get rid of multiplying by negative K? Divide by negative K, Hubert. That's right, class. So T is equal to what? All that trash. Aprende? Probably. Any of the solving. Because how much, let me ask you a question. How much logarithmic rules are on this in a percentage? 10%. What's the rest of it? Algebra. Trying to let y'all know what the secret to passing calculus is. It's not learning calculus, it's how to make sure your algebra, you know it. Because if you don't know your algebra, you're going to have a hard time. All right, which one did I say, 75? Okay, let's do it. That's the same type problem. In fact, it's exactly the same. Not exactly. It says y is equal to capital A plus capital B times 1 minus e to the negative capital C little x, close parentheses. Yeah, this problem I quit. Dang old E. That's just too much to think about. I wish it was log base 10, that way I could do it. That was a hint. See, Mr. Sapp knows what to do. When he can't do it, he quits and leaves.
I'm out of it today.
See. That's what I'm trying to teach all y'all to do, and y'all won't follow along. Y'all keep trying. God. Keep trying to be determined. Y'all suck. A lot easier to quit. Y is equal to A plus B times 1 minus E to the negative CX. And right now I'm not even concerned about what we're solving for because I got to uncluster some of this. And the first thing I'm going to do is bring the A, what? Over. Y minus capital A is equal to B times 1 minus E to the negative CX. And I know dang well it's not going to be solving for B because that's too easy. That would be like pre-algebra. So I'm going to go ahead and divide by B on both sides. And that's going to give me Y minus capital A over capital B is equal to 1 minus E to the negative C to the X power. And now I'm going to bring the 1 over. So that's going to give me Y minus A over B minus 1 is equal to e to the negative cx power. Oops, sorry. All right, let me ask y'all a question. Is there anything else we can do to maybe make it a little bit easier on ourselves? Get rid of that negative. How? Or divide through by -1, whichever one you want to do. Same thing. So I'm going to divide by -1 or multiply through by -1, whichever one you want to do. And that's going to give you, I'm going to put parentheses in front of this. That's going to be negative y minus a over b plus what? 1 is equal to e to the negative cx. Now at this point, you've got it to where you can solve now, but all we've used is nothing but what? Algebra. Now, I want to bring this downstairs. So I'm going to have to use log base 10 or natural log. Which one am I going to use? Log base e, which is what? Natural log. Get used to doing this, especially in differential equations. Okay, because when you do this, when you take the natural log of e, basically it's what? 1, and this comes what? Comes downstairs. Yes, sir. Right here. You can. I'm not worried about it right now. You can. It'd be a minus y. Yeah, a minus y over b, or y minus a over negative b, whichever one you want to do. Well, the only reason I did this was because you're taking the natural log of this right here, so you might want to put brackets right here, because you got to remember, you're not just taking the natural log of this, you're taking the natural log of the whole thing. Okay? And that will be cx, so that cx is going to come down, so you're going to get natural log of a minus y over b plus 1. How does that look? Does that look a little bit better? It's still nasty looking, but it's better than that top one. Okay? Equals negative what? Cx. And what are you going to do with it? Is that a capital C? Does that make a difference? Oh, yeah. And what are we solving for? So divided by negative c. Because in science, capital C is different from lowercase c. That's your answer. Now, of course, you could take that negative and you could work it in here, but I just leave it like this. Once you do one or two of those in your homework, you'll see how they want it. Now, where is the logarithms? The last step. The last step right there where I took the natural log, that middle step right there is the only logarithmic rule that you had to do. And this is just like calculus, because in calculus, and especially in Calc 1, there's only 10% calculus with 90% algebra in each question. So you're getting a good taste of it. And you go ahead and get that drop slip ready. So you can quit, right? No, it's never too late to quit. You can quit anytime. All right, and that's solving equations, pretty much. Okay, when you see one like this, when you see any like these, what's the first thing you should think of? Rewriting with terms of what? An exponent, yes. Anytime. That's just a little information I'm looking to see. All right, here's where you get into your exponential growth and decay. Now, this is important because of you science majors. Some of you science majors, you're going to be seeing this for the next 3 or 4 years, where a lot of engineer and math majors see a lot of, well, engineers, you see your calculus, but you also see your first and second calculus, and you keep on seeing the first and second calculus in statics and dynamics and physics and blah, 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 blah. Well, science majors, they see this exponential growth and exponential decay all the time in all of their courses, because a lot of times they're especially the decay, they're figuring out how long something will last when it rusts, when it da-da-da-da. That's all they. Business, any of your business majors, you're going to be exponential growth, because you want a business major wants to be able to figure out when something's going to die out or when it's going to speed up. You know, dang old stock exchange, all that kind of stuff. All right, I'm not a business major at all. No, never. I couldn't sell an Eskimo a heater, but some people can. Okay, and those are your business people. And that's what these are. So you need to write down a sub o e to the negative kt and a sub o e to the kt. You need to write those down. There they are, right there. Write those down and make sure you understand the definition of the two. The one with a positive exponent is exponential growth, which is business, which is a lot of business applications, versus the negative exponent, which is the one you don't want to see in business. Why? It means you suck as a business is what it means. It means you're losing money. So we don't want to try to work that into our business model. And there is the actual graphs of the functions. I'm not going to spend a lot of time with that. One is good, the other one ain't so good. You ever heard of the term half-life?
Yes.
Half-life is negative. That's your negative. Usually talking about dang old radioactive, dang old stuff to make you turn green. All right?
It's defined as the amount of time that it takes for half of a substance to decay.
That's it. Dang old science major. All right? Finding the age of a fossil. That is called carbon what? Carbon dating. And dang old, you'll see, this is the type question you'll see on a standardized test. Whether it's the SAT test or whether it's, for some reason, they love putting these on those tests. So, not that you're going to get another SAT test, but just take a note, and just carbon-14 is a radioactive form, radioactive, meaning half-life, that is found in all living plants and animals, blah, 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 blah. Using a technique called carbon dating, scientists determine the age of remains by comparing the amount of carbon-14 present with the amount found in living plants and animals. The amount of carbon-14 present after T years is given by the exponential blah, 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 which is your decay. With K is equal to that. The half-life of carbon is 5,700 years. If a fossil contains 1/5 of the carbon contained in a contemporary living sample, estimate its age. So 1/5 of the carbon is there. So 1/5 is the same thing as what? 2/10, 0.2, I think it's 0.2, but you don't have to do that. And you start off with, right there, they give you K, and then there's the 1/5, which is the carbon dating at the beginning. Or the amount of carbon, plug and chug, and you end up basically taking the log of both sides because you have something in the exponent. What do you have in the exponent? What do you have in the exponent? Excuse me. You have T. And what is that? It's a variable solving for. So you plug and chug and take the log of both sides. And why are we taking the natural log? Because it's E. Thus, anytime you have a business model or anytime you have a half-life or decay, are you going to use LOG or are you going to use natural log? You're going to use natural log because it's going to be E. If it's that decay or business model, it's going to be E, so you use natural log. So take natural log of both sides. Okay? And this is your given half-life. Half-life would be 1/2 the initial. Right there. So you have to throw that in there for half-life. When will it say half-life? Yeah. Okay, it'll be half-life or some kind of form of half-life. Okay, let's talk about this guy. Write that one down. That one's another one. Very important application. Why is this one very important? Because all of you are going into business. Is that why it's very important? I have to wait a few minutes. I'll go ahead and write it. I can't write it on the board either. Oh well. Let's see if I can make it come on. Anybody see that light? Is there a light up this?
Yeah.
Orange. All right, reading business. Because everybody's going into business, right? That's why I need to show y'all that one. No, because anytime you're dealing with a bank or you're dealing with somebody who's charging you interest, or giving you interest or charging you interest based on if you're buying or you saving, you're going to be using some form of. It's not coming on. I need it to work. I'm never that lucky. And that is A is equal to P times parentheses 1 plus R over N raised to the NT power. This is one of those formulas that I don't care whether you pass this class or not. It's something that you need to be aware of because it's going to apply to you whether you are using a credit card or whether you are saving money in the bank. Yes, sir. NT raised to the NT power. N times T. I'll tell you what all that is in just a second. Well, just go ahead and go to this page. Let's hold on. A is equal to P times 1 plus R over N raised to the NT power. Ma'am? Mm-hmm. Yes. How did you know that? Did you? Mm-hmm. Well, a lot of your math courses have this in it some way, some form. Because, like I say, it's not only applicable to compound interest, it's also applicable to exponentials as well as You could apply calculus to this also, area under the curve. But anyway, area, this right here is going to be your outcome. This is the number of dollars that you have at the end. I'm not going to worry about this. This right here is what we call the principal. If I can remember how to spell it. P-A-L is like the principal. So P-L-A. Principal is what you put into the bank. Like if you open a savings account and you put in $500, then $500 would be the principal. R. R is rate. And it's usually going to be given in a percent. Do you use percent like that? No. You change it into a decimal. So R will always be calculated as a decimal. So if it's 5%, it would be 0.05. If it's 2%, 0.02. Okay? N. N is equal to the number of times your interest is calculated. Now, the 25-cent word for calculating interest is compounded. Meaning that if you have a bank, John A. Smith Bank, and John A. Smith Bank, you put your $500 in that Smith Bank, and they compound it 12 times a year. That's monthly. Then that means the computer at John Smith Bank, whatever their server is or whatever, it goes through and gets every account number, finds out what the balance is, and it calculates, boom, calculates that month, throws the money back in there, throws that number back in there, throws that number back in there, goes down each one of the accounts and does that. Then the next month, it does it again. Same day, same time. Next month, it does it again. So if it's done monthly, N is equal to 12. So let's write some of those down. If N is equal to 12, that's monthly. So in the problem, it would say compounded what? Monthly. Well, what if N is equal to 4? Quarterly. What if N is equal to 1? Good. What about N is equal to 2? Semi-annually. I'm so proud of y'all. I bet y'all can make a change. All right, semi-annually. You ever seen people can't make changes in 16? I did it close. What about daily? $365. Weekly? 52. Notice, what do these all have to do with? All of them have to do with time. Yeah, that's not what I'm looking for. Number of times interest is calculated, I should put this, throughout the what? Year. 12 monthly, that means year. Annual, semi-annual, compared to a year. So, T is always going to be written in terms of years. Time, money, time principal is kept. And 99% of the time it's going to be in respect to what? Years. So if I tell you that you kept your money in the bank for 6 months, what would T be? Huh? 6.5. Okay? And there are questions on test and homework. I'm not saying this is homework. There are tests that will say, you keep your money in the savings account for 6 months, it's compounded monthly. So N would be 12 and T would be 0.5 or 1/2. Because how many years did you keep it in the bank? Huh? Half a year. 6 months. So, let's say that I was going to get example. Hold on just a second. Let's say that Mr. Pruitt wins the lottery. Okay? And Mr. Pruitt gets a check for $5,500,000. Is that good enough for you, Mr. Pruitt? Since we're, dreaming, I was a little big. 500,000. And he does what most people do. He goes out and buys 2 or 3 new cars. Goes like to do the guy in Texas did. He goes out and puts $500,000 worth of cash in each of the consoles. And what happens to the cars? They get stolen. Okay, so that's what Mr. Pruitt does. Right, Mr. Pruitt? No, hopefully, before he decides to do anything with this check, he will put it in the bank. Let's say, the first redneck is going to say, well, I'm going to put it in the bank, I'll pay all my bills off. Listen, if you put $5.5 million in the bank, are you going to have to worry about any more bills? The bank will pay your bills for you, okay? If you put $5.5 million in that bank, the president of that bank is going to come over to you and say, oh, we'll take care of your bills. We'll take care of them. We'll fix a loan, pay all your bills off. You just put that money in the bank, and you leave it in there for a couple of 5 to 10 years. Well, I want to buy a car. We'll take care of it. Why? Why will they take care of everything? You don't have any idea? Huh? What are they going to do with this $5.5 million while it's sitting in the bank? They're going to invest it. Okay? You're going to make, of course, 2 or 3%. Mr. Pruitt's going to make 2 or 3% off of it. Okay? He's going to make that. It's going to go back in. But what are they doing with that $5.5 million while you're letting it sit in there and be safe? They're investing it. Okay? They're taking 500, they'll take, let's say, $1 million, and they'll buy $1 million of penny stock. Well, of course, they're not going to buy penny stock. They're going to buy stuff that they know is growing. And then they keep it, they buy that $1 million worth, and they keep it in there for 2 or 3 months, and it makes $200 or $3 million, and they put it back in the bank. They sell the stock, put it back in the bank. That's what the banks do with your money, all right? And if you didn't know that, it's your parents' fault. And of course, we all know it's Bush's fault. So he takes that money and he puts it in the bank. And the bank says, now, we're going to you're Mr. Clampett, but you're going to have to keep it in the bank for 10 years. And you say, well, I don't want to keep it where I can't touch it. At least let me be able to pull some money. Okay, put it in the money market. You can draw 3 times a year out of it, okay? Or 4 times a year, whatever. So you decide to put it in the money market. And they decide keep it in there for 10 years. So T is equal to 10. And we're going to put it at 2%, 3%. So R is equal to 3%. And we're going to compound it monthly. All right, so go ahead and figure that up. See what happens at the end of 10 years with Mr. Pruitt's money. What? That's what you're finding out. That's I don't know what it's called. It's called the product. I guess you call it. I don't even know what it's called. You have to look in the book. I think it says it in there. I know it's what the money, the outcome is. I have to look in the book and see. It's going to be 5.5 million times 1 plus 0.03 divided by 12 raised to 12 times 10, which is what? 120. And you take your handy dandy calculator. And we take the handy dandy calculator. And you can do this without even writing it down on paper. It's real simple. You take 0.03 and divide by what? 12. And then you add it to what? 1, Hubert. And then you raise it to the 120th power. And then you multiply by 5,500,000. And that's that number. And let's go ahead and subtract our principal so we know how much we made. 5,500,000. And that gives us that much, which we left it in there for 10 years, right? So divide that by 10. Comes out to be about $192,000 a year. I mean, could you? How many of you could live off $192,000 a year? I could. Yes, sir.
So like, that's no tax, something like that, that's just straight,
Well, it depends on where you put it.
okay.
That depends. That's why you need an accountant. So while he's leaving that money in there for 10 years, or for 5, or for a year, whatever, he's talking to a lawyer / accountant that's licensed both as a lawyer and an accountant to find out what to do with that 5.5 million. He's not going to the strip club in 3 different cars with the console with $500,000 in each console. That's what the guy in Texas did. Except he didn't take all 3 cars to the strip club. He took his truck to the strip club and it got stolen at the strip club, while the other 2 were stolen out of his house
Oh my gosh.
with $500,000 in the console. Huh? I don't know. Probably lived in a trailer knowing this guy. I mean, he wasn't too bright.
How many rental properties do you think you could buy?
Oh my gosh. There's no telling. Depends on if you get them at tax foreclosure sales or not. But now, this is exaggerated, of course. I'm exaggerating a little bit, but you're also talking about $5,500,000. You know, and it might be a lower percentage. I don't know what the percentage. I'm just using 2 or 3%, but you'd have to talk to your local bank. But that is that's behind this. Where is it? Right here.
Do banks seriously like pay your bills and stuff?
What they would do is take out a simple interest loan, or take out it's called where you don't have to put up collateral. I can't remember the name of it because I've gotten them before with like tractors and stuff. And they just pull out a loan and they use what you've got in savings or whatever as collateral. So let's say if you skip the country and you borrowed $5,000 to buy a car. Well, they got that money year tag in your savings account, $5,000. They're not touching that money. They're letting you borrow that money. And if you kept your job, let's say you kept your job working at, I don't know, White Jones or whatever, and you could make those payments, or you could get them to take the payments out of the money and it would go toward that loan. You see what I'm saying? In other words, unsecured loan. That's what it is, unsecured loan. In other words, you could pretty much do whatever you wanted to. They wouldn't pay your bills, like not take it out of your money. No, they're not going to do that. But what I'm saying is they would not let you go without just because you wanted, instead of $5,500,000, you say, well, I'll just put $2 million in there because I need to live off. No, we'll take care of you. In other words, they want that money in there. And they would do anything they could to keep you from taking that money out. They would rather you take it out a little bit at a time than to take $2 million out and put it in another savings account.
Unless you do like Billy Ray Cyrus going to the drive-thru at the bank trying to withdraw $1 million.
No comment.
Thinking that they give it
I'm
to
not, he doesn't register to me. I think he was an idiot to begin with. Anyway, sorry. And they go through and tell you how to do it. What is A anyway? What does it stand for? Does it say? I'm sorry, what? Okay, accumulate.
The amount they have for some years.
Well, why don't they just call it that? Okay.
So we just saw for what the bank made, not what the actual guy made,
No, that's what you made.
that's what he made.
Yeah. Okay, now this guy right here this right here will make you sick. This right here, if you took the 103, it makes you sick. Does anybody know why this one will make you sick? It will make you sick because you actually find out how much money you spend when you buy a car. or a house. So let's look at this one. Now I'm gonna rewrite it, okay? This right here is 1 over I. They give you I negative n. Negative n again is, but I'm gonna change this right here. I'm gonna rewrite this and I'm gonna put this over 1 and I'm gonna flip it. So I can change this right here to a positive n. So yeah, they're gonna give you that. Okay, so let's do this one. I like to tell people to do this right here. Not for the grade, but so you can use it in real life, because after you see it, you're going to be like, oh, okay. Thanks for telling me that, Hubert.
I think it's weird that they put the period after the formula.
I'm not even looking. Hold on a minute. I'm going to pull that out. I don't want to rewrite that. Oops. Okay, so let's take this guy. There he is. And the only thing I'm going to do different is I'm going to rewrite it, because I don't like the way it's written. I'm going to take, you see this right here? This right here is over 1. So I'm going to rewrite it. R is equal to P over 1 minus, and I'm going to put this over 1. 1 plus I to the negative n over 1 all over I. This bottom part is over I. Now, I'm going to flip this right here. Why am I going to flip this? Because if I flip this, it'll make this negative n what? Positive n, and it won't give you a connection when you see it. And the calculator goes negative, and you put the wrong negative in there. Instead of the little negative, you put the subtraction symbol, and then the computer blows up. And then you blow up, and then you want to quit school. So R is equal to P over 1 minus 1 over 1 plus, I don't like doing that because it's getting all cluttered up, and I don't want to do that. All right. I flip this, so that'd be 1 plus I to the n power, and that's over I. And that bottom part is like that. Or, can I multiply P times the reciprocal of this? Yes, you could. And that would be P times, the reciprocal of this is 1 over 1 minus 1 over 1 plus I to the n power. So that's another way to do it. You could either take P and divide it by this, or you can take P and multiply it by this. Either way, it doesn't matter, but I like to use the positive n power. I do not like to use this right here. I don't like to use it. All right, so we're going to take this guy, and we're going to copy him, and we're going to move him over to the next page. And I'm just going to take the example that they give us in the book right quick. Let me find it. Let's take this guy. Let's take this snip. Okay, so let's say instead of a a camper, let's say that you buy a car. Okay? Just forget about the camper, just say a car. And it's $24,000. You can buy, I don't know, I haven't bought a new car in so long. I guess a $24,000 car would be like a little sedan, you know, a Taurus sedan or something like that. Something that's kind of not expensive but not cheap. It's kind of in the middle. I don't know how much a new car is now, so I may be talking out my neck. All right, so you purchase a camper trailer for $24,000. After a down payment of $4,000, the balance will be paid off in 36 equal monthly payments. All right, 36 equal monthly payments is important. 36 monthly payments. Now, let me ask you something. What is the payments going to be based on? The years that you what? Finance. All right. So I'm financing this one for how long? 3 years. 3 times 12 is 36. So 3 years at what? 4.5 interest. So that's going to be what? 0.045. 0.045 is going to be our rate, or I don't know what they call it, probably I don't know what they call it because they're changing variables on me. I think that's equal to the I, but we'll get to that in just a minute. So we've got this, and we've got this, and you purchase a camper trailer, but you, after a down payment of what? So how much are we actually, now the way I'm reading this is, you purchase a camper for 24, you pay 4,000, so how much? 20,000. All right, so there's your numbers that you have to work with. The I, there probably is saying R over N, but just hold on, let me check. Because I've never seen them use I before. Usually it's R over N. Where is my handy dandy? There it is. I is equal, yeah, R over N. Change I to R over N, or say I is equal to R over N. Okay, it makes life a whole lot easier. And NT, or 36, they give you 36. Okay, I was right. I just want to make sure. Sometimes they use that. All right. So, and did they use, they did use 20,000. I'll make sure. Should be 20,000. Or do they want to do the whole thing? No? Yeah, 20,000 right there. Okay, just wanted to make sure I was reading it correctly. Because sometimes I don't read it correctly. All right. So here we go. Let's plug and chug. So 1 plus, this is going to be what? We know our N is equal to 36, right? So this is going to be R over N. I'll get it. Which is 0.045 divided by 36. Somebody take 0.045. Well, I'll just do it in the calculator right quick. 0.045 0.045 divided by 36 is equal to that number right there. So that's I. All right, everybody got that? All right, and what are we going to do to it? We're going to add it to what? 1. We're going to raise that to the 36 what? Power. Now I've just done this denominator, right? Now I've got to put it over under what? 1 divided by that number. Is that number right there. And 1 minus that number is equal to that. And then that number, put -1 under that number, would be a positive, but I ain't worried about that. So -1 divided by inverse answer is equal to that number, and multiply that by 20,000, that what we got? $572 what? Dollars a month. Everybody with me? That's your payment. $572 a month. Now how many months we got it for? Times 36. And that's equal to $20,597. Did I get that right? Let me make sure. Yeah, times 36. Let's see what we got so far. I got 594. I must have done something. No, I got 572. I must have done something wrong. Let's see how quick. Hold on. Let's see what they got with. Did I not get 0.33? Let me try that again. 0.045 divided by 36. Nope. 0.045 divided by 12. Oh, okay. I'm sorry. Where did I get 36? I thought you. Okay, my bad. It must be I is equal to R over N, not R over NT. I did R over NT. I'm sorry. So that would be 0.045 divided by 12 is equal to, okay, my bad. Let me go back to my formula. Okay, now that's plus 1 equals raised to the what? 36 power. And then I'm going to subtract that 1 minus inverse answer is that negative, and 1 divided by inverse answer should be positive. 1 divided by, somebody take, oh, I didn't divide negative. Okay, still 6.9. And then 6.932 multiplied by 20,000. And subtract 20,000. Now you know why I'm not a banker. I can't get it to come out. I'll have to, it's getting close to the end of the class anyway. Basically, what do you end up, what's the total interest that you paid for the car? $1,417 is what you paid. Now that's pretty good. If you ever tried doing this with a credit card, you will get sick. But I gotta figure out what I messed up. See, I'm not used to dealing with that I. I'm used to dealing with N over T. All right, y'all get on out of here. Let me call the roll right quick. I'm sorry. I ran out of time too early. Let's go with, I think we're probably talking about the test probably toward the end of the week. Because the only thing I've got to cover now, since I've covered decay and interest, the only thing I've got to even think about is graphing, which we already can do that with the graphing calculator. All right. Huh?
So like when you think Homer's gonna be doing stuff?
I'm sorry, what?
When you think Homer's gonna be doing stuff?
Probably the end of the weekend or something like that. Y'all should be doing it anyway, so it shouldn't be that big a deal. Anderson's here. Barron.
Sure.
Borf. Crane. Crenshaw. DeVore. Evans. Fisher. Hall. Keller's here. Lou's here. Moore. Nix. Pace was here. Page was here. Where is Pahela? What is Pahela? Pahela. Where's Pahela? Where is he at? Pruitt's here. Sabb's here. Sloger was here. Stone. Walton. Woods. No Woods. See ya.
Hey, on board,
Yeah,
she had to leave early. Her husband.
I saw,
had an issue.
I saw her leave. I didn't know there was something wrong.
Yeah, she had like a bad asthma attack and she had to take him to the hospital.
I figured something was wrong. Okay. Well, I'm glad you told me because I know she was here. I just wanted to make sure. Okay. I'll fix it for her. Yes. Got it.